Why has the scientific community never reached a definitive conclusion about the origin of oil? Perhaps because the standard answer itself is wrong. Most people imagine the formation of oil like this: a prehistoric Earth teeming with dinosaurs and plant life. These organisms die, are buried deep underground, and slowly transform into petroleum over millions of years. It sounds scientific, but a little bit of math and basic physics quickly exposes its flaws. First, let's look at the numbers. Global oil reserves are estimated to be in the trillions of tons. However, scientists have calculated that the total biomass of all life that has ever existed on Earth is nowhere near enough to account for that amount. On top of that, the conversion rate of organic matter into crude oil is incredibly inefficient. Most dead organisms are either decomposed by microbes or oxidized long before they can be buried deep enough to undergo that transformation. Only a tiny fraction of organic matter ever survives to become part of the petroleum generation process. Then, there's the geological evidence. If oil were truly of biological origin, it should only be found in sedimentary rock, where organic matter naturally accumulates. Furthermore, at depths greater than a few kilometers, temperatures become so extreme, often exceeding 300 degrees Celsius, that any remaining organic matter would break down into natural gas, or be reduced entirely to carbon, rather than remain as liquid crude oil. Yet, the reality is very different. Oil has been discovered in non-sedimentary rocks, such as granite and volcanic formations, where no significant organic deposits could have accumulated. Even more strikingly, major oil reserves have been found at depths exceeding 10,000 meters, where temperatures reach several hundred degrees Celsius. Under those conditions, no biological material could possibly survive, let alone transform into liquid petroleum. This is where the abiogenic petroleum theory enters the picture. As far back as the 19th century, Dmitry Mendeleev, the creator of the periodic table, proposed that oil was not biological, but inorganic. He argued it was formed deep within the Earth's interior through chemical processes, not from decayed life. This theory was later put to the test during the Cold War. Western geologists, firmly committed to the biogenic model, insisted that large swathes of the Soviet Union were barren of oil, simply because they lacked the thick sedimentary layers required for its formation. However, Soviet scientists, trusting the abiogenic hypothesis, took a massive gamble. They drilled directly into crystalline basement rock, formations that had been written off entirely by Western experts. The results shocked the world. They struck enormous oil fields, most notably in the Dnieper-Donetsk basin, securing a steady supply of energy for the USSR throughout the Cold War. Despite this overwhelming practical success, the abiogenic theory was largely sidelined and marginalized by much of the Western scientific establishment for decades afterwards. So how could this happen without life? From a chemical standpoint, it's entirely plausible. The Earth's mantle is incredibly rich in both carbon and hydrogen. At depths of hundreds of kilometers, under extreme temperatures and pressures millions of times greater than at the surface, carbon and water can react directly to form hydrocarbons, the very building blocks of oil and natural gas. These hydrocarbons, once formed, are less dense than the surrounding rock, so they migrate upward through cracks, faults, and fissures in the Earth's crust. Eventually, when they encounter an impermeable rock layer, they become trapped, forming the oil reservoirs we extract from today. If this is true, oil is not some fossilized remnant of ancient life, but a primordial fluid, continuously generated by the Earth itself for as long as its internal heat and pressure remain. But perhaps the most conclusive evidence isn't found on Earth at all. In 2004, NASA's Cassini spacecraft arrived at Saturn and deployed the Huygens probe onto its largest moon, Titan. What scientists discovered there was nothing short of revolutionary. Titan, with surface temperatures of negative 179 degrees Celsius and no possibility of supporting life as we know it, was found to be covered in vast lakes, seas, and river systems. But these weren't filled with water. They were filled with liquid methane and ethane. Even more remarkably, Titan experiences methane rain, carving out a full hydrological cycle, but with hydrocarbons instead of water. According to NASA's estimates, Titan holds hundreds of times more liquid hydrocarbons than all of Earth's known oil and natural gas reserves combined. And yet, Titan has no dinosaurs, no forests, no algae, and no microbial life to speak of. The only logical explanation is this: hydrocarbons are not rare biological byproducts, but are naturally abundant, inorganic compounds found throughout the cosmos. They form readily in the extreme conditions present during planetary formation, in nebulae, comets, and within planetary interiors. When Earth formed 4.6 billion years ago, it likely inherited vast quantities of primordial hydrocarbons, trapping much of them deep within its mantle. That means human civilization may not be running on the leftovers of prehistoric life, but on a cosmic inheritance, locked away inside our planet since its birth. For 4.6 billion years, that energy remained sealed beneath our feet, until the invention of the drilling rig finally unleashed it, igniting the engine of modern civilization. Ultimately, while the biogenic theory may explain some oil deposits, it cannot account for all of them. The abiogenic theory, backed by deep drilling successes, geochemistry, and extraterrestrial evidence from Titan, offers a far more complete explanation for the sheer scale, distribution, and abundance of hydrocarbons we see, both on Earth and beyond. The truth is likely not one or the other, but a combination of both. However, one thing is certain: oil is far more primordial, abundant, and cosmic than we were ever taught in school.